back to Budz React, guys, and today we're doing another science video. Another one that's gonna give me a headache for quite some time because it's another science video about space, and the title of the video says "Plot twist: There's no dark matter. Our theory of gravity is broken." The video is brought to you by Secrets of the Universe channel. If you have a sec, go check them out. Make sure to like, comment, and subscribe to our channel. If you like to see these reactions, like to see what our insights. They're not very educational, but
Just see our
our little
our stupid
tidbits.
mediocre reactions to this. Like basically, we're learning it alongside.
Yeah.
But yeah,
Um,
be sure to go to their channel, check it out. We'll leave their link in the description down below.
all right, let's hop right into it.
Evidence against the standard model of cosmology. They have discovered a
Can't tell if
theory
it's
that
too
could
loud or not.
replace
It's kinda
dark
loud in
matter
my ears.
and ultimately solve one of the biggest mysteries in astronomy. The new theory is called AQUAL and implies that dark matter may not exist at all. The researchers tweaked Newtonian gravity to fit the observations of galaxy rotation.
Where did we come up with the name Aqual? Come on now. Hello?
Dude,
Like
I don't know.
how?
They come up with the craziest names of things in space. Every star they name is like SC85556389. Like what?
Uh,
Curves. Besides correcting a possible 90-year-old
I don't think we really know much about dark matter anyway. So like, who knows what's?
let's just theorize.
I know. That's why I
Same
love.
thing with dark energy.
That's what I love about theories.
mistake, their results may open new windows to the fundamental understanding of gravity itself. But what happened 90 years ago that changed the course of cosmology? Why are physicists developing an alternative theory of gravity? Finally, and most importantly, how can the new idea lead us to a better understanding of the universe?
I'm not gonna lie, I thought there was gonna be some kind of cool little like intro music right there when it was like zooming in.
That's pretty dope.
So used to hearing that Curves channel.
Dark matter is one of the most important entities in the standard model of cosmology. It is a hypothetical form of matter believed to make up 27% of the observable universe.
68%.
The problem
dark energy. I
is
thought it was 70%.
that dark matter does not interact with electromagnetic radiation, making it difficult to detect directly. Instead, its existence is inferred from its gravitational effects on visible matter, radiation, and the large-scale structure of the universe. Even the standard model of particle physics doesn't contain any elementary particle representing dark matter. Although scientists are pretty confident that dark matter exists, they are still trying to understand its properties and behavior. Their goal is to develop a definitive
You understand all those formulas, right?
Yeah.
Yeah.
theory
Just make
that
sure.
explains
Sigma
its nature.
pi equals mc squared. I know all this.
To understand AQUAL, it's important to learn how dark matter even came into the picture. It was in 1933 when Swiss astronomer Fritz Zwicky noticed something was missing in the
Solid
universe.
name.
He studied galaxy clusters and concluded that the observed mass of matter was not accounting for the total mass of the galaxy cluster found based on the motion of the galaxies held together by the gravitational force. He discovered this discrepancy in the Coma cluster. Zwicky first calculated the mass of the Coma cluster by studying the galaxies at its edge.
This is what makes no sense. Like what?
So, like black holes, you know what, you know what confuses me about black holes is they can come up with like images, not images, but like illustrations of how they work and how they suck in like stuff towards their center and stuff like that.
Mm-hmm.
But then you know then you look at galaxies, like images of galaxies, and they say that black holes are at the center of galaxies, but you can't see any black dot. But yet they come up with like these graphics of black holes sucking in like all this matter around it, around like this circular black object. So it's just confusing.
I mean, we don't even know what's inside a black hole. We just assume.
He then compared it with the mass based on the brightness and the number of galaxies in the cluster. The two values didn't match. As a result, he obtained evidence for an unseen type of matter which he called dark matter. Supporting his study came American astronomer Vera Rubin's analysis of galaxy rotation curves. A galaxy rotation curve is a graph of the orbital speeds of visible stars or gas in the galaxy versus their radial distance from the center. A rotation curve for our solar system looks like this. The average rotational velocity of planets in their orbits around the Sun decreases as their average distance from the Sun increases. So, the farther a planet lies from the Sun, the slower it goes around it. Mathematically, their orbital speeds are inversely proportional to the square root of the radial distance from the Sun. However, Rubin and her colleague Kent Ford found that the stars in the galaxies did not obey such rules. In fact, it's the opposite. Almost all stars in the galaxies revolve around the center at increasing speed as the distance increases. They noticed that the outer regions of these galaxies were rotating at the same or increasing speed as the inner regions.
Makes no sense to me.
Yeah,
Zero
what?
sense
Which was
made.
unexpected based on the known distribution of visible matter in the galaxies. This seemed only possible if there was a significant amount of unseen matter in the galaxies. Just like Zwicky, they referred to it as dark matter. With time, more evidence in favor of dark matter poured in. First, in the 1980s, the observation of gravitational lensing of background objects by galaxy clusters supported the presence of dark matter. Then, in the 1990s, measurements of the cosmic microwave background and the large-scale structure formation of the universe hinted that something like dark matter must exist in the universe. Specifically, these observations showed that the universe is much more clumpy and filamentous than one would expect if it were composed of visible matter alone. Although the concept of dark matter is strongly established in modern cosmology, there's a big problem. Scientists are not sure what comprises dark matter.
Yeah, that's like the whole thing. We just don't know, and like, I guess
This is
anything that
why-
you would send in, you would lose signal, and you just
You
hey,
know,
we need a volunteer subject, JJ. Let us know what's on the other side.
yeah. If my head hurts from all this stuff, I'm sure the people that actually understand this, like, are infinitely more perplexed than I am.
Dude, those people are they're on another level. I'm telling you, aliens.
As stated earlier, there's no elementary particle in the standard model that makes up dark matter. The hunt for such particles is still going on. Several candidates for dark matter have been proposed, including weakly interacting massive particles, massive compact halo objects, exions, and sterile neutrinos. Scientists continue to search for
I don't know
dark
what
matter
any of those
particles at the Large Hadron Collider. Through
That-
experiments such as
I know that the Hadron Collider. That's where they like do like a test with like extreme power and like speed or
CREST,
something like that.
Lux, Zeppelin, the Exion Dark Matter Experiment, the Xenon Dark Matter Experiment, and the dark matter maps from the Dark Energy Survey.
Probably got that completely wrong.
But if you
But
can't see dark energy, how do you get a dark energy survey?
So far, all these experiments
These
have
are the
returned
things that the
empty-handed.
simulation wants us to figure out.
So naturally, one would think,
You were
what if
frozen
there
for a
is
second.
no dark
Back.
matter at all? What if this is a flaw in our understanding of gravity itself?
What if the dark matter is just a bug in the computer programming?
We're not in a simulation.
I mean, it's looking kind of like it to me.
No.
Many
we're
teams
not
of
in a
researchers
simulation.
are on a quest to find alternatives to dark matter. One such alternative is called the Modified Newtonian Dynamics, or MOND.
Mon.
It involves the modification of Newtonian gravity to apply to the galaxy rotation curves. Since Newton's laws are highly tested and valid for high acceleration systems like the solar system, MOND, proposed by Mordechai Milgram in 1983, took a step towards a modified gravitational force law for an
Those eyes. He looks like he knows a lot.
Yeah.
extremely
He's holding a
low
lot in that
acceleration
Looks like a
brain.
environment.
smart person.
Yeah, he's just holding so much information in that brain.
This theory
It's
assumes a
crazy.
threshold acceleration
I want you to solve that for us real fast.
That his whole skull is just full of brain. There's
Dude,
no empty space.
that brain is fully functional. Like,
below which there is a
God, some of these people are
transition
just so
from Newtonian
intelligent.
dynamics to Mond regimes.
Unbelievable.
Based on this idea, a generalized theory was constructed by Milgram and Jacob Bekenstein in 1984. It's called A-qual, which stands for A quadratic Lagrangian. This theory modified Newtonian gravity by
Yeah,
changing
I
the
knew that.
classical Lagrangian to a Lagrangian involving a general function and the threshold acceleration term.
Makes
What's a
sense.
Lagrangian?
Makes sense. Makes sense.
Yeah.
The currently accepted cosmology model is the lambda cold dark matter model, or the LCDM model. Let's understand how it's different from the A-qual hypothesis.
Dude, it's just it makes you just think about all the jobs out there that just like the normal people like us just don't even know that exist. That are just these super smart people and these science jobs and tech jobs. It's
Hey,
like how people reverse engineer stuff or just like come up with like these theories and tests. Like, dude,
if they could make learning more fun, I would go back to college. But
no,
sitting through a college
the
lecture is
tests
not.
and lectures and stuff are so stupid.
Yeah.
It's not how you do it.
There are two important parts of every galaxy's rotation curve.
How much more like when you go to like a job orientation, you don't learn anything in the orientation. You just listen into
No,
you're just
you're
like
just
getting through
listening.
stuff. You don't learn
Yeah.
things till you get on a job until you're hands-on doing something. That's when
Hands-on,
you
yeah.
pick things up. Like that's how life should just be.
Curve.
Hands-on
The
learning.
inner one,
teach
which is a
people.
rising curve, and the outer one, which
Maybe I would understand some of this if that happened to me when I was growing up.
is slightly increasing or almost saturated. These parts correspond to the motion of stars in the inner and outer regions of the galaxies. Since
It's just fascinating to me that like we just like they people have an understanding of all this stuff that's so far away that you can't touch or be like physically near. But we have so little knowledge of so many things near like on Earth and like around us.
the
crazy.
LCDM model attributes the galaxy rotation curves to the presence of dark matter, the distribution of matter should account for both the inner and outer portions of the rotation curve. On the other hand, A-qual asserts that the transition caused by the galaxy dynamics accounts for the difference between the inner and outer portion of the rotation curve. The small kink in the curve is due to the slight change in the velocity distribution between the inner and outer stellar motions. That's how the LCDM and A-qual models differ. Now this is where the new study by K.H. Che comes in. It chiefly focuses on how differently modified gravity and dark matter explain the inner and outer proportions of the rotation curves. He studied 152 galaxies observed in the Spitz.
You studied 152 galaxies.
You know how much time he spent probably studying those galaxies?
Like science has just come so far.
Solid couple years at least.
Dude, things have just come so far in like our lifetime.
Photometry and accurate rotation curves, or the SPARC database. He aimed to determine the theoretical possibilities of distinguishing dark matter and modified gravity. To do so, Che studied the statistical relation between the observed centripetal acceleration of particles in motion and the expected Newtonian acceleration from the distribution of baryonic matter in the galaxies.
That's high vocabulary.
I was
That
just
is
gonna
high
say,
vocabulary where I don't understand.
it's crazy
a word
that
he's saying.
people like this are just having like conversations and it's just like, yeah, I got what you meant. I understand you. Yeah,
The
yeah.
baryonic matter
It's
Why
wild.
this is why when you ask a scientist to explain it to you in regular person terms, it's because they use words like that.
Yeah, can you put things in layman's terms for us, please?
corresponds to stars and
Jeez.
dust. The dark matter model showed a larger scatter than the SPARC data. The SPARC data of 152 galaxies considered in this paper supported A-qual better than the LCDM model. He noticed that only under the application of cosmic mean external field
Looks like
did
an
the
eye.
A-qual modified gravity predict correctly both inner and the outer parts of the rotation curves. This study has presented a detailed analysis of A-qual and its potential to provide new insights into the nature of gravity. Although the results are exciting, A-qual has its own drawbacks, as it cannot thoroughly explain the observed gravitational lensing by galaxies. but this study is a step towards understanding the theory's pros. It's possible that just by tweaking Newtonian gravity, we can solve one of the biggest puzzles in cosmology and astrophysics. Recently, scientists simulated a black hole in a lab that mysteriously started glowing. This experiment has enabled them to have a deeper understanding of Hawking radiation. You can watch this.
Okay, so
All right, well.
yeah, I mean we're on top of it. So
We're just,
basically, the black hole creates a sun creates okay, we're on a new theory process here. We're on something different.
Just gonna go blow up science and start again.
Jeez, dude, you know what we need to look into next? We need to deep dive into like pyramids and stuff like that.
Oh, how they were formed? Yeah.
I
that
know
would be
we're never gonna get the answers I want for like another till I'm dying, but like man, I want some answers on that stuff. Anyway, guys, if you enjoyed this video on this mind blowing, I mean, if you guys actually followed along with that,
Yeah, if
y'all
you
are
can
way better than
understand
us.
it, let us know. If you can actually understand every word that's said here,
Yeah,
let us know.
if you solved one of those equations, or you understood what one of those equations actually meant, or if you could actually read one of those equations out to me, you let me know. But till then,
and then explain it to me in simple terms.
yeah, layman's terms, and then till then, hit the like button, subscribe, comment down below how dumb we are, and check out one of our funny animal videos, way better. I mean, we understood what's going on there.
Yes.
We understood in the animal videos what's happening. So check that out, and until next time, guys, we'll see ya.
All right, y'all. Peace.
Peace.